Alright, I want to discuss this very important topic that's sort of skimmed over many times, and I plan to skim over it here as well. First thing I want to do is analyze the difference between x plus x and x times x. Um, X plus x is simply 2x, because this is 1x plus another x, that's 2x. Multiplication is a shortcut for addition, right? That's what we're doing here. And then x times x is x squared. Exponentiation is a shortcut for multiplication. So keep these things in mind. Now let's compare other similar things such as 2x plus 3x and 2x times 3x. 2x plus 3x is simple, that's 5x. In this one, we need to think a little more deeply about this. Everything here is multiplication. Even 2x is 2 times x. So you want to think about this as 2 times x times 3 times x. And since this is all multiplication, you don't have any addition or subtraction mixed in, you can multiply this in any order that you want. So you could reorder it to make it 2 times 3 times x, which is 2 times 3 is 6. X times x is x squared. Now, you may think this is sort of the long way around to get 6x squared, because now you can look back and say that it's obvious, but you really should think about it this way until you're very comfortable with these sorts of properties and understanding that this is all multiplication. You know, up here you've got multiplications, but then they're separated by addition, so that's a bit different. Now let's talk about x squared plus x and x squared times x. X squared plus x, there's nothing you can do with that. That's simply x squared plus x. You have 1x squared and 1x. You can't combine those. They're not like terms, is what we call them. Here, however, x squared is a shortcut for writing x times x, so that's the x squared part, times another x. And x times x is, we can write using an exponent as well, making this x cubed. So here, there are 3 x's being multiplied, which means you have x cubed. Here, you cannot combine these, okay? If we do have something like x squared plus x squared, though, that's 1x squared plus another x squared is 2x squared. X squared times x squared, well, this is x times x times x times x. That's x times itself 4 times, which is x to the 4th. So pay special attention to the differences between these things. Terms where the variable is raised to a different power cannot be added to terms where the variable's to some other power. Alright, so that's kind of the point. Let's look at some more complex examples now. Let's look at a times x plus y, and what we've got here is multiplication on the outside and addition on the inside, and this is what the distributive property is good for. It helps us to combine this multiplication with this addition somehow, and the way we do that is we distribute the a over the plus. So it goes to the x and then it jumps over the plus and goes to the y also, and we get ax plus ay. Okay, not too bad. But now let's look at something like x minus 2 times x plus y. Well, it's the exact same thing, except now we take this entire polynomial and we distribute it to x and we distribute it to y. So we end up with x minus 2 times x, just like a was times x up here. Plus, right, because we've got to jump over the plus, this x minus 2 times the y. Finally, this x is multiplication and this is subtraction, so we distribute this x over the subtraction in each case. Distribute the y over this subtraction, and we get x times x, that's x squared, minus 2 times x, so that's minus 2x, plus x times y, minus 2 times y. And none of these terms can be combined. There are none of them that are like terms, and so this is what we get. So multiplying complex things like this is still simply the distributive property.